All right. So I'm Christopher Agillian.
Hi, and I'm Oliver Physiok Fox, and this is our project on biodiversity and phytoremediative ability associated with artificially constructed floating wetlands in the Ottawa. Wait, it's not. Okay, there we go.
Now, I did want to go over what a healthy stream looks like before we fully dive into this presentation. So, a healthy stream has clean water and it also is abundant with native biodiversity. And as you can see from this chart over here, you can see the native Hawaiian species, and you see some of the most common invasive ones that have been introduced in our streams.
And one of the important parts about a healthy stream is the presence of a balance where there's not vast changes happening overnight. And one of these things that can upset the balance are heavy metals. And if you look at the Alawai Canal, that's an example of a stream that isn't healthy. And one of the reasons for that is because of the high levels of pollution that have upset the balance of native and invasive species and have encouraged invasive species to come and take over. And the heavy metals present in high amounts in the Alawai are lead, copper, zinc, and cadmium.
Now, in Hawaii, there have been numerous introductions of invasive species. And so these are some of the most common ones that are found in the Alawai Canal. You can see the tilapia, the mangrove goby, Mexican mollies, and as well as various species of catfish. And then from the literature that we read, we found that over 90% of the species in the Alawai Canal's watershed are invasive.
So our research had two questions. The first was how effective are constructed floating wetlands at removing heavy metals from the waterways of Oahu?
And how effective are these mats at recruiting native biodiversity and enhancing that in our streams?
So you might ask what exactly is an artificially constructed floating wetland? And a constructed floating wetland is a mat of plants that is floating in a waterway, generally tethered to something. In our case, it was a cinder block. And the mat does multiple things. The first thing that it does is absorb pollutants from the surrounding, including heavy metals, through a process known as phytoremediation.
And the mats also have the plants are basically semi-immersed. So the stems and the leaves are on top and the roots are below the water. And they are commonly on top of a net of sort of a net of sorts. Whether that be natural or artificial.
And the mats also support animals living in them and are often referred to as nurseries for animals.
Now to give this study some background context, these mats have been used in the past before. So they've been used in freshwater ponds, like from the literature that we cited. And then we've also seen these mats have also been used in some more saline conditions like lagoons, or more specifically a stagnant lagoon, which is more like the Aloi Canal. And then they've also been used in many cases to absorb pollutants, such as this example over here when the mats cleaned up de-icers from an airport.
So the two plants that we had on these mats were Akuli and Ai, and we chose these plants for several reasons. The first reason is that they're both native Hawaiian plants, and because of that, they can help better support native Hawaiian animals, and also hopefully not support invasive species as much. The second reason is that because they're incredibly hardy plants, and that they're even considered weeds amongst gardeners. And because of this, they live very well in harsh conditions like the alawai. And a kuli especially is very successful in salty environments and is almost considered as a beach plant. You'll see it at a lot of beaches, actually.
Now, before going into this project, we of course had to construct the mats. The square ones were very easy to construct. However, the circular ones were not as easy to construct. So for the square ones, we first started out with some PVC pipes that we cut, and then we filled them with foam, and then we connected them using 90-degree joints. And then afterwards, we overlaid coconut erosion cloth on top of it, and then this is the finished product. For the circular ones, they were much harder to construct and they're much more time consuming. So we had to heat sand, and then we had to pour the sand in a pipe, and then the pipe had to be bent around kind of this frame over here. And then there's a picture of us cooking it, and then that's the finished product.
Right. Um, yeah. So the mats were tested prior to deployment in the Alawai, and we did this actually right out there in the artificial pond. Um, and they were tested in several ways. The first was that they were used to support the plants in the water just to see that they could, and to see that the netting worked the way it was supposed to. The second way we tested it was that we did a weight test where we filled a bottle with sand and we measured the amount of and you can see it in that picture there. We measured the amount of weight it could take before it started sinking. For the square ones, we got over 5 kilograms, and for the circular ones, we got around 2.5 kilograms.
And then it's also worth to note that we did try a bamboo design because the it's not like the PVC ones, which like plastic. We tried that in the artificial we on the artificial pond on this campus. However, the mat could barely support like even just the weight of the plants, and it didn't make it to the deployment in the Alawai Canal.
Right. So the mats were first deployed in the Alawai in late November, and again in late February, early March. And they were in the water for about a month. So you can see on the map there the small red circle, and that's the area that the mats were deployed, and they were taken out after a month for testing.
And then we also so it's pretty notable to say that we had to put white signs on the mats because we found out very early on that people take these mats out of the water because they think it's maybe like some kind of fishing trap or trash possibly. And then also we ended up using cinder blocks to anchor the mats, and then we used rope up and we tied that to the frame of the mats. And then they're also generally about the same area, like within at least
20
20, yeah,
meters.
20 meters of each other.
Um, and for the second round of testing, we kind of strayed away a little bit from the tying the mats directly to the cinder block, and we used a clip floater system. That's a lot easier to disconnect, which saves us a lot of time, makes it a lot more convenient to collect data.
Now for collecting the data on the biodiversity aspect, we used a seine net to collect the animals. So we took the seine net, we put it under the mats, and then we pulled it up. And the animals were caught inside the seine net on top of a very fine mesh net. After that, we placed it on the land and we counted each of the animals and put them into separate buckets. We also had a biologist there to identify the animals as we went. And it's also notable to say that it was really, really time consuming to hand count each of these animals.
Yeah, so across 6 mats, it took us 3 days, 3 separate days of counting, and it probably took 8 combined hours across all 3 mats. So that was really time consuming, and we're working on better identifying the fish and the shrimp ourselves. So hopefully we can streamline that process in the future.
Now through our research, we found multiple animals in and around the mats. So we saw juvenile herons and mallard ducks that's sitting like on or like hunting near the mats. And then whenever we stayed in the mats, we found aquatic animals like the mangrove goby, the Mexican molly, and the opahuna. And then around the mats, we've seen fish like tilapia and catfish. Now, in general, the mats were very successful at attracting wildlife, with this one having almost 300 animals total. And then we also calculated that this is about 80% of native species out of the total.
And it's important to mention that these mats are very small. The square ones are 52 by 52 centimeters. The circular ones are 49 centimeters in diameter. So when you take this almost 300, it's 284 animals, and you divide that by the area, you get over 1,000 animals per meter squared, which is a very high concentration of especially native animals. So data for heavy metals was also collected after a month, and this was done by taking clippings of both the stems and the roots of the plants, and multiple things were tested. The first being the concentration of heavy metals in the plant, and the second being translocation factor. Translocation factor is the ratio of metals in the stem to the root, and it's a measure that scientists use to determine how well a plant is able to absorb metals without poisoning itself too much first. The higher the translocation factor, the better a plant is at storing the metals in a safe place. So, both plants were very successful at absorbing copper and zinc, which were the two metals that we've tested so far. They scored well within the range for known phytoremediators. And they had a translocation factor well within the range of known phytoremediators. And this is especially impressive given that they're in the Alawai Canal without any medium. So they're absorbing all of their nutrients from the Alawai, and all of the things that they need from the Alawai, which is obviously a less than perfect situation for them. So the fact that they're able to absorb metals so well in bad circumstances is very promising. So the constructed wetlands absorb pollutants very well, and these pollutants actually end up in the water for many reasons. Uh, some of the major reasons are just runoff from the streets, where even things like tires use metals. So our tires are galvanized with zinc, and that's something that lets them stay together. But when they wear down, those ions end up in the water, and these mats help take the ions out of the water and into the stems.
Now, I did want to mention some very important aspects that significantly affected our data. The first one would be that whenever we took the II monoculture mats out of the Alawai Canal, we found that there was basically no coconut erosion cloth left on them. And that was reflected in our data with the II monocultures having almost no animals. And so there was very little surface area for animals to go on. So there were no. And it's also notable to say that there was at least some damage on every single one of the mats, such as this one over here. However, this one still had some animals.
All right. So there's currently a second round of testing ongoing. And we have changed up the experiment a little bit. The first way that we've changed it is we've broken up the distribution of the mats. So instead of three groups of two mats with an akuli monoculture, II monoculture, and a mix, there's now two groups of three mats based on the shape of the mat. So there's three squares in one group and three circles in another group, and they're located very closely to where they were previously located.
And then we've also integrated new aspects such as clips to make staining the nets easier, floats so we can access the clips much easier. And we've also added more layers of coconut erosion cloth, so it is much less likely that the plants will just fall out. And then we've also observed new animals on the mats, such as the aforementioned ducks and fish.
And one of the other things that we've changed in the second rounds of testing is that we have started new data collection, including testing the salinity of the water, testing the temperature of the water, and testing the light in the water using a mixture of tools, including especially the hobo, which is that little thing on the clip right there. It's actually supposed to be in the water. It got washed up, but it's back in the water now. And what that does is it collects temperature and light data every minute and it stores it. So when we connect with our phones, we can actually tell like if there's been any major changes. And the same thing with the salinity that might cause the plants to die, and it tells us that like hints for why things might go wrong or why they might have gone wrong in the future. So there are a few alternatives. The first is dredging, but that causes some pretty major habitat destruction. And the second is Genki balls, which a lot of you guys have probably heard of. But the issue with Genki balls is that there's not very much research on them. We don't actually know how the efficacy of them. And because of this, they're not very scientifically supported. So they work in theory, but there's not actually been very much data collected on them, and it's incredibly hard to actually see if they have any real effect. So the helpful thing about our mats is that you can actually see the hard data and you can quantify it.
And through our research, we've found many things. We've found many future applications for these mats. So for one, the square ones are very easy and inexpensive to build, which means that they can be deployed on a mass scale, as you can see over here. And then if these mats are to be produced on a wide scale, it's definitely possible that we would see a lot more recruitment of native wildlife, and then that native wildlife, the data that is collected could be added to Hawaii's databases, and then we can also improve the literature that we found.
Right. So there's another part of this project, and that's the elementary school outreach part. And we are currently reaching out to 3 elementary schools, including Iolani, but also Jefferson and Alawai Elementary School. And these elementary schools are all located very near to the Alawai, so they have easy access for these projects. And we thought that these projects would be useful for elementary school age children because they're very simple. The mats take maybe 15 minutes to construct, um, and they provide a good introduction into ecology and learning about the streams of Hawaii in a hands-on way that they can actually learn from and hopefully have fun doing. The other thing that this part of the project does is, if successful, it will provide 4 times as much data because we'll have sets near each of those schools, which would mean a lot more information about metals, a lot more information about animals. We could also use this to tell the distribution of animals based on the different concentrations in the different areas.
So through the research process, we learned a lot. So the first one would be that you definitely want to start early because it took a long time for us to construct and then deploy and then collect data for the mats. And um, also we learned that you definitely want to document your progress, whether that be through like a journal or definitely taking pictures. We found taking pictures to be very, very helpful. And then you also want to be prepared for big changes. As in our case, it could have been like a big rain or people taking the mats like literally out of the water. And then definitely, yeah, definitely take photos of your project. At least for our project, since like environmental science. So that was very, very important.
And it might get serious towards like science fair or even something like this, the science symposium. And you might be crunching, like having to crunch time a lot. But I think it's also important to remember to have fun because this is like you're teaching yourself and you're learning a lot. And that's always fun for this project at least. Right, so there's our citations for the papers, our image citations, and we'd like to say thank you to Dr. Chan, Ms. Kobayashi, Dr. Perez David, Dr. Carl Berg, Mr. Aranaga, Ms. Churuk, Mr. Yap, the school, and our parents. Okay, thank you.